So this is a multi-locus genotype probability problem where basically you can see that there are multiple loci, or basically multiple genes in each parent that we're crossing to get the child. So in lecture, Dr. Putzel showed you how to do this using probabilities, but in this video, I'm going to show you how to do it using Punnett squares. So the idea here is not to make one huge Punnett square and try to cross all of these loci at once, but to do 4 smaller Punnett squares for each locus. So as you can imagine, on a test, it might be pretty time consuming to do 4 different small Punnett squares every time you see a problem like this, but I think this will be useful for practice before the exam, and once you get comfortable doing a lot of Punnett squares, then you might be able to start doing them in your head and do them more quickly that way, so on an exam you won't waste much time making Punnett squares. So the approach here is to just look at, say, the first locus. So let's just look at E. So we can see at this locus, at this gene, we have one heterozygous parent, another heterozygous parent crossing to create a homozygous dominant parent. So a homozygous dominant child. So we would make a Punnett square for just these parents. So it would be a heterozygous parent and another heterozygous parent. And then we would look at the resulting genotypes, and we would see that the child, the genotype we're looking for, homozygous dominant, there is a 1 in 4 chance that we get this homozygous dominant genotype from these heterozygous parents. So we can do the same thing for the next locus and the next gene, so that would be F. So when we're looking at only the F genes, we can see that it would be a homozygous dominant and a heterozygous, making a heterozygous child. So if we just do this Punnett square, we find that 2 out of 4 of these possible genotypes created by this cross create the heterozygous child that we want. So that would be 2 out of 4, or the probability would be 1/2 chance. So let's say we're doing this on a test and we're trying to think it through quickly in our heads with this third locus. So, well, let's think about it. The first parent only has big G's, while the second parent only has little g's, and we're looking to see if the child is heterozygous. So and we know that each parent has to contribute 1 letter to the child, and since this parent is only going to contribute a big G and this parent is only going to contribute a little g, then there is a 100% chance that we're going to get a kid with a big G and a little g genotype. So then this would be a probability of 1. Now let's double check our thinking here. If we cross these parents in a Punnett square, we'll see that we were right. There is a 4 out of 4, or a chance of 100%, that we get this heterozygous child from these parents. So this last locus is slightly different. We can see that from these parents we're looking for a child where we only know that it's showing a dominant phenotype, that there is a big H in it. This means that this child can be either homozygous dominant or heterozygous. So if we do the cross, we'll see that these two have at least one big H in the genotype. And these two are both homozygous recessive, so they don't apply. That means there is a 2 out of 4 chance, or 1/2 chance, that we get at least one big H in our genotype. In this case, they're both heterozygous. So now that we have all these individual locus probabilities, we got to think back to our laws of probability. We want to find out the probability of creating a child with this genotype and this genotype and this genotype and this genotype, which means we have to multiply this probability by this probability by this probability by this probability. So if we want to do that, we multiply 1/4 by 1/2 by 1 by 1/2, and we'll get 1 out of 16. And if you have your calculator with you, that would be 0.0625. So that means that the probability that the cross of these two parents with multilocus genotypes will create this child with this genotype is 1 out of 16, or 0.0625. I hope this Punnett square method of multilocus genotype problems helps out, and good luck on your test.